Yes, students, good morning. Welcome to our video lecture. Today, we are going to start section E of exercise 4 and continue with the tabular method. Section E, exercise 4. Main question 1, part 1. The given function is y is equal to fx is equal to 5x plus 7. So given, we have to check limit x tends to 2, y, which is 5x plus 7 is equal to 17. That's what we have to prove. Okay, so y is equal to fx is equal to 5x plus 7. Okay, students, now pay attention. As usual, we prepare the table. We shall take the values of x. We shall take the values of x very close to 2. And prepare the following table. This is what we are writing the steps. And prepare the following table. Now, students, in the table we are making this columns: x corresponding fx, x corresponding fx. Draw the number line as usual. I am telling. So this is 2. Left hand side value is 1. Right hand side value is 3. So students, we can approach 2 from two sides, either from left side or from right side. I told you always shift. Point 1. So 2 minus 0.1. So the left hand side values will be 1.9, 1.99, 1.999 and 1.999 and onwards. Right hand side values, shift 0.1, 2.01 and take one more decimal, 2.001, 2.000 and onwards, students. Now, fx is 5x plus 7. So when I take 1.9, students, 19 5s are 95. So 9.5. 9.5 plus 7. 9.5 plus 7. So 16.5. Then, when I take 1.99 into 5. Now students, pay attention. 1.99 into 5. So if I multiply 1.99 into 5, 9 5s are 45. 9 5s are 45 plus 4, 49. And this will be 5 and 4, 9. 9 plus 7. So it will be 16.95. And this will be 16.995. This will be 16.9995. And onwards, check, this is approaching 17. Okay, now students, if I go for the right hand side values, 2.1. 2.1 into 5, so this will be 10.5. 10.5 plus 7, so this will be 17.5. Then students, let us take one more value and showing the multiplication so that you clearly understand. That is my, you can say, intention, students. 2.01 into 5. So this is 5, 0, 10.05 plus 7. So 17.05. then 17.005, then 17.0005. Check, this is approaching 17. So our next step will be, it is clear from the above table that it is clear from the above table that when the value of x, that when the value of x is brought nearer to 2, then what we write? By increasing or decreasing its value, by increasing or decreasing its values, we write the value of f of x approaches the value of f of x approaches here 17. Therefore, as x tends to 2, y tends to 17. Therefore, limit x tends to 2, 5x plus 7 is equal to 17. Mind you, this is approximated. I have told these students n number of times, exactly 17 we are never getting. Students, this is approximated as 17. The answer is never exactly 17. So I hope now, students, by this time you can say this type of sums are crystal clear to all of you. Okay, let us go for sum number 2, section E, question 1. Now here y is equal to 3x square plus 16x plus 16 upon x plus 4. Okay, let us change the function. Our function is different. This will change always as usual. And here also we will make changes. And this will change always. Okay, students, our function is different. Question 2, and it is limit of x tends to minus 4. Okay, and the function is 3x square plus 16x plus 16. 3x square plus 16x plus 16 divided by x plus 4. So if I take here x is equal to minus 4, then the denominator becomes 0. So let us simplify 3x square plus 16x plus 16 upon x plus 4. So 16 3s are 48. Simplify or factorize 48 to get 16. 12 4s are 48. 16 3s are 48 and 12 4s are 48. 12 plus 4 16. 3x square plus 12x plus 4x plus 16 upon x minus 4. Take 3x common. So bracket will be x plus 4. Take 4 common. So bracket will be x plus 4 upon x plus 4. So students, x plus 4 into 3x plus 4 upon x plus 4. X plus 4 gets cancelled. So our function is, so fx is nothing but only 3x plus 4. So we shall take the values of x very close to -4 and prepare the following table. Now immediately students draw the number line. -4, left hand side -5, right hand side -3. Now in negative, be careful. One or two students called me and they were asking the doubt, students, how to shift, sir, how to shift for a negative side. So that fact, students, or that particular, you can say, fact I am here restating. So students, be careful. When I shift point 1 to the left for negative side, this will be -4.1. And here it will be, students, when I shift point 1 to the right, this will be -3.9. That you have to be very, very careful. See, if it was -5, then to the left it is -5.1, and to the right it is -4.9. Like that, students. So we have to be very careful. I told this before also, and you can check this, students, in, you can say, one or two examples also we had. Check example number 6. We had this example number 6. So this will be -4.01 -4.001 and -4.000. Here, students, it will be -3.99 -3.99 -3.999 and onwards. So we have to be, students, very, very cautious about the negative value, students. These are increasing, these are decreasing. Now, students, our function is only 3x plus 4. Check here. Our function is 3x plus 4. Okay, and what we have to prove that this limit, answer of this limit is -8. Okay, so this we have to prove as -8. Now, pay attention. When x is -4.1 into 3 will be -12.3 plus 4 will be -8. Then, students, I am writing here for this. Let us take -4.01 into 3. So first of all, I am not writing minus, so this will be 12.03 and plus 4, so this is -8.03. Shift one. This will be -8.003. This will be -8.0003. So check. This is indeed very close to -8. Now, students, let us go from the right hand side. So if x is -3.9, so first of all 3.9 into 3, 9 3s are 27, 9 and 2, 11. So this will be, you can say, -11.7, and if I add 4, then the answer is -7.7. Now suppose this is 3.9. Let us again multiply. Check. 9 3s are 27. 9 3s are 27 and 2, 29. So this will be 11. And if I add 4, it will be -7.97. This will be -7.997. This will be -7.9997. Check, this is very close to -8. So it is clear from the above table that when the value of x is brought nearer to -4, by increasing or decreasing its value, f of x approaches -8. Therefore, as x tends to minus 4, y tends to minus 8. So, limit x tends to minus 4, the function is 3x squared plus 16x plus 16 upon x plus 4 is equal to minus 8. Exactly, it is never minus 8. This fact I have reiterated 25 times. This fact I have reiterated, students, 25 times. Again I am reiterating. So be very careful. Okay, students. Now let us do the third step. The function changes, so correspondingly all our calculations will change. This value will change. This will change. Sum number 3. Okay, let us check what is the question. Students, okay. The question is, using tabular method, prove that limit x tends to minus 1. 3 upon x plus 1 does not exist. Okay. Limit x tends to minus 1. 3 upon x plus 1. So here we write the given function is fx is equal to 3 divided by x plus 1. No need to simplify this. Since factorization is not possible, minus 1, left hand side is minus 2, right hand side is 0. So we can approach, students, we can approach minus 1 from left as well as from right. So we shall take the values of x very close to minus 1 and prepare the following table. If I shift point 1 to the left, it is minus 1.1, minus 1.01, minus 1.001, minus 1.001 and onwards. To the right, if I am shifting, this becomes minus 0.9, minus 0.99, minus 0.999, minus 0.999 and onwards. Okay, students. Now, please concentrate. If I am writing here minus 1.1 plus 1, so this will be 3 divided by minus 0.1, so this will be minus 30. So here I am writing minus 30. Then here it will be minus 300. Then minus 3000. This will be minus 30,000. Definitely, students, we can say that as x tends to minus 1, f of x is not approaching a common value. Okay, let us take from the other side. 3 divided minus 0.9 plus 1, so 0.1, so this will be plus 30. This will be plus 300. This will be plus 3000. And this will be plus 30,000. Check. These are significantly different values. F of x is not approaching a common value. So, it is clear from the above table that when the value of x is brought nearer to minus 1, by increasing or decreasing its value, the value of f of x, the values of f of x does not approach a common value. Therefore, limit x tends to minus 1, limit x tends to minus 1, 3 divided by x plus 1 does not exist. exist, hence true. So every time, students, these are stereotype common sums. Now, students, I am very sure that by this time, students, you would have now understood how to do this type of sums. Okay, now main question 2, we are starting with sum number 1. Let us write this much again. We will erase this. And this much also I have to erase. Let us erase this minus 1. It is a different value always. Okay. Now, students, we are going for section E, main question 2, part 1. Main question 2, part 1. What is given is limit x tends to 5. Limit x tends to 5, x square minus 3x minus 10 upon x minus 5. Now, if I factorize this fx, then fx is equal to x square minus 3x minus 10 upon x minus 5. Factorize 10 to get 3, 5 2s are this much all of you know. So minus 5x plus 2x minus 10 upon x minus 5. Take x common, so x minus 5 plus 2 into x minus 5 upon x minus 5. So the two factors are x minus 5, x plus 2 upon x minus 5 gets cancelled. So our f of x is only x plus 2. Very simple. Draw the number line. 2, right hand side is 3, left hand side is 1. We can approach 2. Students, from 2 sides, either from left hand side or students from right hand side. Now, as the value of, we shall take the values of x very close to 5 in the following table is, sorry, students, here it is 5, sorry, by mistake I wrote 2. So this will be 4, this will be 6, sorry, students. So we can approach 5 from 2 sides, either from the left side or from the right side. If I shift 0.1 to the left, this will be 4.9, 4.99, 4.999, and 4.999. If I shift 0.1 to the right, 5.1, 5.01, 5.001, and 5.000. So if I get 4.9 plus 2, then students I will get 6.9, then 6.99, then 6.999, then 6.9999. So this is very close to 7. Here 7.1, 7.01, 7.001, 7.0001. So this is very close to 7. So as from, it is clear from the above table that the value of x is brought nearer to 5 by increasing or decreasing its value. The value of f of x approaches 7. Therefore, as x tends to 5, f of x tends to 7. Therefore, limit x tends to 5, f of x is equal to 7. Even I don't write function and write in general, students, f of x, then also it is absolutely correct. So students, by this time now I am very much sure that students, all of you are well versed in in the sums of limit by tabular method. Don't get confused for negative. Once again I am explaining for negative part. Suppose say this is minus 7. X approaches or x tends to minus 7. Left hand side will be minus 8. Right hand side will be minus 6. On the number line, as you go on the left side, you will get lesser values. So when I shift point 1 to the left, I have to write minus 7.1. And when I shift point 1 to the right, I have to write minus 6.9. That much all of you clearly understand. Suppose it is minus 8. Now when x tends to minus 8, when I am shifting point 1 to the left, I will write minus 8.1. And when I am shifting point 1 to the right, I will write minus 7.9. So be very careful. This much only students you have to perfectly understand. So don't get confused whenever we have students a negative constraint, a negative value. Be very careful. On the number, as you go towards left, values goes on decreasing, and as you go towards right, the values goes on increasing. This much students we have to perfectly remember. But remaining questions of main question 2, you should try to do the homework. Definitely we will discuss in the next lecture and complete section in main question 2, part 2, 3 and 4. So here students we conclude the lecture. Thank you students.